Remember, it's important to always review the charts you intend to use for a given instrument flight. Planning and preparation before taking off will make you a safer and more competent instrument pilot. The information we've covered so far is primarily aimed at traditional approaches, such as ILS, localizer, VOR, and NDB approaches. But the world of aviation navigation is changing rapidly, and so are approach charts. This next segment is designed to explain the changing technology and terminology that you'll see on Jeppesen approach charts. With the widespread deployment of area navigation systems and the advent of satellite-based navigation, greater flexibility in defining routes, procedures, and airspace is now possible. To capitalize on the potential of these new technologies, the FAA, in conjunction with the International Civil Aviation Organization, ICAO, has introduced a new standard of navigation and airspace management called Required Navigation Performance, or RNP. The theory behind RNP is to establish one performance standard that applies to aircraft, airspace, pilots, air traffic controllers, and international aviation authorities. This single performance standard is enabling the widespread use of area navigation, or RNAV. The term RNAV no longer refers solely to the VOR station mover of the past, but rather encompasses several different types of navigation equipment. The heading RNAV applies to GPS, INS, VOR DME, and LORAN-based navigation systems. When a specific RNP standard is given, such as the ability to maintain a course of 1 nautical mile on either side of a course line, it doesn't matter how the RNAV system calculates position, as long as it provides navigation that meets the specified required performance. A given RNP level is applicable to a specific route, airspace, or procedure. The RNP value is expressed as a distance in nautical miles. Currently in the United States, there are 3 RNP levels: 0.3, 1.0, and 2.0, but additional RNP levels will be added. RNP 0.3 represents a distance of 0.3 nautical miles, or 3/10 of a nautical mile, on either side of a specified center line. At the present time, a 0.3 RNP level is the highest level. An example of this RNP level is the specific performance required on the final approach segment of an instrument approach. An RNP level of 1.0 is typical of that used to define a terminal route. And an RNP level of 2.0 is the width typically used for en route operations. You need to have a clear understanding of the aircraft requirements for operation in a given RNP environment, and advise ATC if an equipment failure or other malfunction would hinder your operating ability within the designated RNP airspace. When appropriate, the applicable RNP level will be depicted on IFR charts. For example, the Baltimore, Maryland RNAV GPS runway 10 approach chart includes a notation GPS or RNP 0.3 required. Aircraft that meet RNP criteria have an appropriate entry in the aircraft flight manual or its approved supplement, including any conditions or limitations. The implementation of a worldwide RNP standard marks the beginning of a fundamental change in air navigation. The FAA, in cooperation with the aviation industry, is designing an entirely new system of navigation to take advantage of these changes. The next generation of air navigation will be a satellite-based system. It will be known as the GNSS Landing System, or GLS. GNSS stands for Global Navigation Satellite System. The major component of this system is the GPS satellite system currently in use. GPS signals will be augmented by ground-based stations known as WAAS, or Wide Area Augmentation Systems, and LAS, or Local Area Augmentation Systems. GLS will allow GPS to be used for non-precision approaches as well as Category 1, 2, and 3 precision approaches. GPS and other area navigation systems are becoming more commonplace as new electronic navigation equipment is being developed and installed in commercial as well as general aviation aircraft. In order to support the full integration of area navigation into the National Airspace System, the FAA has developed a new charting format for all RNAV instrument approach procedures. This format incorporates all types of approaches that use area navigation systems, including ground-based, satellite-based, and other approach-approved systems. The goal of the new RNAV charts is to avoid the unnecessary duplication of charts. All GPS approaches, both unaugmented, today's GPS, and augmented, WAS and LOS when operational, are published using the same new chart format. The approach is titled RNAV (GPS) and the runway number. The Tallulah-Vicksburg GPS runway 18 is now the RNAV (GPS) runway 18. Also, when multiple RNAV approaches to the same airport runway exist, the procedure name includes a letter code beginning with the end of the alphabet. The Baltimore-Washington International Airport has the RNAV GPS Zulu runway 15 right and the RNAV GPS Yankee runway 15 right approaches. One of the approaches contains LNAV VNAV, lateral and vertical navigation minimums, while the other approach includes LNAV, lateral navigation minimums only. Another change in the heading section is the way decision altitudes are portrayed. The lowest decision altitude or minimum descent altitude is still given. However, it is referred to as the LNAV VNAV DA parentheses H or the LNAV MDA parentheses H. New notes will also show up on RNAV charts in the heading portion of the chart. You may see requirements for the approach, such as radar required, GPS or RNP 0.3 required, DME RNP 0.3 not authorized, and Baro VNAV not authorized below minus 15 degrees Celsius. Some RNAV systems utilize barometric pressure readings to generate a computer-guided vertical navigation path. This is called Baro VNAV, and in this case, it is not authorized for use below minus 15 degrees Celsius. Some systems calculate lateral positions based on DME readings. If your system operates by DME triangulation, you are unable to use the LNAV VNAV minimums for the Yankee runway 15 right approach. Since every system operates in a different manner, you must have a thorough understanding of the operational capabilities of your GPS or FMS system in order to comply with these requirements. The MSA on RNAV charts also contains an important difference. The MSA is predicated on a waypoint, such as the missed approach waypoint, instead of a navigational facility. However, the MSA does not exist on all RNAV charts. Rather, a terminal arrival area, or TAA, is incorporated into the approach and acts as an MSA. A TAA provides an efficient method for aircraft to transition from the en route structure to the terminal area for an RNAV approach. TAAs are charted on the plan view to represent one of three arrival areas: left base, right base, and straight-in arrivals. The TAA also provides multiple initial approach fixes as well as an intermediate fix for the approach and are designed to reduce the need for procedure turns. Flyover and flyby waypoints are also in the plan view. A flyover waypoint is depicted by a four-pointed star with a circle around it. This type of waypoint is typically used for a missed approach point or missed approach holding point when it represents a specific point in space that must be flown over. A flyby waypoint is typically a position in which a change in the course or procedure takes place. It is represented by a four-pointed star. You can anticipate and begin your turn prior to reaching the waypoint, resulting in smoother transitions. Now let's take a look at the different things you may encounter in the profile view of an RNAV chart. To further enhance aircraft operations using RNAV approaches, vertical navigation information is published in the profile view. This symbology represents vertical descent information that is coded into the navigation database. It provides guidance to allow for stabilized, constant-rate descents on selected non-precision approaches. The VNAV information in the profile view illustrates the geometric descent path and descent angle from the final approach fix to the threshold crossing height at the approach end of the runway. The descent angle appears in brackets along with the descent path. Notice the descent path is a screened dotted line. The descent angle and ground speed information can also be found in the conversion table on the chart. The TCH, or the height at which the descent angle crosses the runway threshold, is also depicted in conjunction with the descent angle. The actual height in feet is stated over the end of the runway. The inclusion of VNAV descent angles does not preclude the use of minimum descent altitudes or missed approach points. You cannot descend below the MDA unless the required visual cues are present. One very important change to the profile view is the appearance of notes on some non-precision approaches. In the profile view of this VOR DME approach, you see a ball flag and a note stating, "Only authorized operators may use VNAV DAH in lieu of MDAH." This tells you that the DAH operational techniques apply to operators who have obtained permission from their controlling authority. Use of the DAH operational technique is subject to appropriate flight crew training, proper equipment, and operator approval. Contact your local FSDO for more information regarding the authorized use of VNAV decision altitudes. Also new to the profile view of selected Jeppesen RNAV approach charts is the addition of a figure that denotes the distances from the last fix to the decision altitude and the decision altitude to the missed approach point. On this chart, the distance from the last fix to the decision altitude is 0.8 nautical miles, and it is 1.1 nautical miles from the decision altitude to the missed approach point. The last major difference you will find on RNAV charts is a new descent minimum format and new terminology. The new RNAV chart format may include as many as 3 approach minima: LNAV VNAV, LNAV, and circling. LNAV VNAV identifies minimums developed to accommodate a non-precision RNAV instrument approach with lateral and vertical guidance. Aircraft capable of using LNAV VNAV minimums will make their final descent using a descent path generated by onboard navigation equipment. Since vertical guidance is provided, the minimums will be published and flown as a decision altitude, even though it has higher non-precision approach minimums. When determining your ability to use the DA for LNAV VNAV minimums, you must take into account the notes listed above the plan view on the charts that were previously discussed. LNAV minimums are designed for non-precision approaches that only provide lateral navigation. Because vertical guidance is not provided, the minimums will be published as an MDA. RNAV approaches and procedures are rapidly increasing in number. As this new technology becomes more commonplace among pilots, it is important to remember the burden rests on the pilot when determining the ability to use RNAV procedures. Information is continually added to FAR and AIM publications in order to expand the use of RNAV. Contact your local FSDO if you have any questions regarding the use of your navigation system for RNAV operations.